Anyway, so it did work. Let me run it again. A is not equal to 1, and I put A1, and I get A is equal to 1. Right? This is commented out. It's not coming from here. It is coming from here. In switch, what did I do? I said I have an integer A, so switch on A, and then I make case 1, system out, print line 1. And then I have to do break. If I don't do a break here, when I do a break is a command that breaks out of a block statement. So it will break out of the switch statement.
What does that mean?
So everything goes line by line, or how your logic takes it. So the program came here. It said, okay, now I have to switch. It checked case for 1. Okay, so it said yes, A equal to 1. So when I say switch on A, then A becomes on the left side, right? And the case becomes equal 1. So it said, okay, this statement matched. So it will not match any other statements. It will come here and start executing here. But it will start executing till it finds a break. On the first break, it will come out of this block state. And whatever is outside, it will do that. So let's put it system.out.println outside of switch, right? And then what I'll do is I'll copy this. Musa, you need to practice. Do what I'm doing. You are the teacher of 2 people. Alright, so now I have 4 case statements, right? 2, 3, 4. But say I do not put a break here. So I comment this out, right? So if I say A is equal to 2, I already sent it to you guys, so I will delete this. So if I say A is equal to 2 and execute, it will print there. I forgot something here. Alright. If I say A is equal to 2, it says A is equal to 2, and then so what happened? It matched only this one. It did not match 1, right? So it came directly on 2. It printed A equal to 2. It did not come to 3 because there was a break. After it, so it did a switch, came to 2 because A was 2 at this time. It printed that line. It came to break. Break took it all the way out to here. And then it printed outside of switch, right? And let me put A is equal to 3. Same thing, no difference, right? So let me put A is equal to 4. But this time, we see difference. When it came to switch, A was 4, it jumped to 4, case of 4. It printed 4, but there was no break because break is commented out. So it kept going. It did not find a break. It went to default. It printed the default also. Sometimes, if you do not follow exactly like this, you even have to put a break here also, so that it can, at any time where you want it to stop, it stops and goes outside of the block statement. But anyways, this break is additional, but this break should be here, and then it would be a good code, right? Should I send it out for a switch code? Switch is very interesting, and switch is very important. But a lot of times you can do what you can do in switch, you can do a little bit more with if else, lot more with if else. Because why? Because every time on the else side, on the next if, there was another bracket where you can have any new condition. So it becomes very powerful. But for a cleaner code that is only taking condition on one variable, which is A in this case, then switch statement is very clean. It makes it very easy for you to see how the code is doing, what path it would take or it might take, or how the paths are set up, right? So that was about conditional statements to begin with. So we did talk about basic conditionals, block statements, scope variable defined in the block. So last thing that I want to, not last, for this part is to talk about scope of a variable. All right, we don't need another else as such. Right, so basic conditionals, you guys should have some understanding. So of course we have to build on previous ones. So you should have good, and you already have the reading stuff and everything. So, and if you have any questions or any problems, then of course you can send questions, and I will answer. Some other person will answer. Yes.
Would that still work without the brackets?
Yeah.
So, what I'm trying to ask is like, what is the point of brackets?
No, what if you want to have more than one statement? So it did right? What if you want to have more than one statement? So you want to write system dot out dot print line. I am so happy that you are the one. How about that? Right? Now I want to execute it, right? So in the if part, I want to print two lines, or I want to execute two statements, any two statements. I want to execute. It is not happy. Semicolon is one problem. It is still done. It says else without an if. It says it says yes, this is fine. If, then I will execute just this line. This much is fine. And then this line is also fine because it is taking it as a second line. But it's saying then why this else if? It cannot connect this else with this if. Because this if is only for one line. And why is it? Let me explain to you again. Let me comment this out. So theoretically, A is equal to 2, right? So it should print A is equal to, it should not print this first one and just print the second one, right? So it will run this time. And it did not print the second one. It did print just the second one. But that was not the intent. The intent was that if A is equal to 1, then you should execute these two lines. Right? Because that's the comment also. It's all about 1. So if you understand it or not?
This is confusing.
Right. Because if you don't have a block statement, then if is only for one statement. So you guys see what happened?
Why did it skip the first line?
You understand what is happening? Say, what is happening is it checked A is just go ahead.
I'm gonna say, so in this case, the if was false, so it just ignored that whole statement, right? And it just went straight to that second statement?
Right. So if it, because in this case A is equal to 2, right? So if is false, so it ignored the first statement.
It just
Why
went-
did not ignore the second statement?
it just went to the next line of code.
Because it's
It's
It
a
is-
line.
it is one line only. The if is only for one line. But sometimes you don't want it for one line. You want it for multiple lines. So what do? You put it in a block statement. Right? So if I put it in a block statement, then now the if is for these two lines. I executed, it did not print anything. Because if false, the whole block statement was skipped. If a is equal to 1, the whole block statement was printed. You understand what I'm saying? So if is a condition, you want to apply it on one line, then don't put block statement. You want to apply it on multiple lines, put all those lines in a block statement. Same with else. So I can have like this, and then I can have an else, right? Now this else would work. This is it. And you have two lines, right? But if I make it 2, it will execute if a is not equal to 1 or 2. But say I want to write another line and say a is not equal to 1 or 2. So what is a? Now this what is a will be taken as outside of else because it's not a block statement. So whatever happens, so what is a will be printed. Right? Because this becomes out of if or else because it's not in a block statement. So to put it in a block statement, I put it in a block statement. And now it will print only when it has to be printed within a block statement. So that's why the block statement, right? Question, Brother Abdul-Bari.
Yeah, I was just making sure I was with you. So block statement, like you could have 100 lines of code that are all based upon one if statement, right? So I'm thinking like in a video game, if user presses whatever button, 100 things will happen, all within that one block statement. And if user doesn't hit that button or doesn't activate that if statement, then it just skips to the next line of code.
Exactly. Right. And of course, it means we'll see a lot of other things that help us do that in a more orderly ways and stuff. But from a conceptual point of view, you are 100% right. Now, what happens is, and I don't have to format it, but it just looks a little bit better. Now, if a is equal to 1, I say int z is equal to 100, right? And then I also print z right? A is equal, has to be 1, right? A is equal to 1. Z is equal to 100. Fine. This is good. But what if so I say why, so if A is equal to 2, I also want to put z is equal to 100. But it doesn't like z. It says, where is the z came from?
Also the block.
And I say, no, z is defined here. So two things here. First of all, it is not even in the, it is not, if a is not equal to 1, then that block statement has not even executed. When it's not even executed, then how can I expect z to be 100 or z to be there? Because z is not even initialized because we have not even gone there. Alright, that's a fair thing, right? A is not even executed. I say, okay, fine, I will put it outside. Right? So now it is not part of if, and I will make it a is equal to 1. And I will execute it, and it will still give me the same error. Because Z is defined in a block. Even if we have a chance that the code will go into this block, this variable that is defined in this block is not visible outside. If you have one block and within this block you have another block, then the code is visible, then we have Z visible in that block. If I say if, let me define another variable, int b is equal to 1, right? And I say if b equal to 1, and then I want this to be printed, and let me just take it out so that we are not confused, and a is equal to 1. Within this bigger outer block, so usually it is called outer block and this is called inner block. If Z is within this outer block, then Z is good because it is defined within this outer block. You can use it within an inner block. But if it is defined in one block, you cannot use it in other block. This is one type of scope of a variable. Variables have multiple scope restrictions. This is one of the scope restrictions. And scope restriction is just simple thing. Where is it visible? Would the variable be visible here or there or in this case or not? Alright, so we did talk about scope of variable defined in a block. We come to logical expressions. I'm trying to do more things like, so because we don't have a lot of time, and I want to make sure that I do not keep you guys for just 15 minutes. So logical expressions, homework. Switch statement we did. Loops, I want to start loop. So that otherwise because we'll have to finish somehow a little bit. And we'll talk about all of those. You can see that even today I'm talking about some of the variable stuff, some of the other concepts. So we will come back to this time to time. You can always ask questions, but you've seen one thing today about logical expression. What was that? No, switch was a logical statement. Yes, that's true, but logical expression. So what is mathematical expression?
Integer.
Like integer, no, integer is a variable type. Mathematical expression is a mathematics of integer, for example, or algebra, right? No. Equation, right? Mathematical equation is like a mathematical expression. Logical equation is like a logical expression. So today we saw one type of logical equation. What was that? Equal to. A equal 1, right? That was a logical statement. The statement was saying compare A with 1, actual processor inside processor, and it compares, it takes variable A into one thing called register, another thing called register, and compares the registers. So It's actually, so it does a comparison. So comparison is a logical operation, right? You compare age and you say equal or not equal. For example, if you're checking for equal. But you can compare age and say greater than or less than, right? So say, is Abdul-Bari younger than Musa or older than Musa? Of course, the result is younger than Musa. But I'm just saying that it's a logical comparison, right? So logical comparison is equal, is greater than, less than, and we know how greater than and less than works, right? So instead of A equal 1, I can say A greater than 1. Right? This is normal greater than. People understand it? I can say greater than or equal to, but you guys have to see all, to check all of that. I can say less than. I can say less than or equal to. I can say not equal to. It's an exclamation mark. So all of those are logical, right? So I can say equal, right? What if I want to say equal, if A equal to 1 and B not equal to 2? That's a logical operation, which means it will do check A equal to 1, then it will check B not equal to 2, and then it will check that they both can be ANDed. Now, I'll let you guys read about it and everything, and I'll send, if it's not part of this reading, I'll send it, the reading for it. But there are two main things, and or, and then equal, not equal, greater than, less than. So and or, you might have a little bit of effort understanding it, but equal, not equal, everybody understands. You just have to try different things, practice it so many times that you don't have to really think again about it. But those were logical expressions that that's part of the homework. So what is, let me add, logical expressions. Alright, loops. We just have few minutes, so I want to start the concept of loops. It's a very interesting concept, just like logical expressions or conditional statements. Conditional statements is a very big part of the whole program. Loops is also very big. So whatever we're talking about are the basic building blocks of the program. These concepts, once you understand, once you master, then it's what is called transferable skills. These skills transfer to any programming language that you use, even some other than programming, right? Because this is all logic, this is all very basic stuff, and it helps you in thinking and understanding. Because programming is all about thinking, understanding, and planning how you want something to happen. So if you have a good programming mind, you would have a very good planning mind also for, say, for your day, for your other things, because programming is also planning. Once you want to write a program that does few interesting things, then you have to first plan. You have to say, how will I write it? What I'll do first, when I'll take user input, then what are the conditions, how I will put a condition there, how much loop it needs to do, and stuff like that. Anyways, let's go to loop in a few minutes that we have for today. What are loops? So what happens is that we wrote some program, they were all very nice and good, but what if the program is, instead of I put int I is equal to 1, right? And we have said one of the homework that you guys have is that you will put, instead of int I is equal to, int A is equal to 1, you will put a statement there that will take a user input. And then the user now can say, oh, instead of A, I want to put 5 in A. And then you will, down below, you will do some conditional statement and then print something, right, based on the variable that user has given. But you want to run over and over, so that user can put some value and then it returns some other value for it. So a lot of times what happens is, for example, you have a mathematical expression that you want to run, right? But it's not that you want to run it one time. You run, say for example, you want to run over and over. Or say you want to run an expression on all the variables 1 to 100. And then see, within that, you want to see which one has a result, say 450, or closest to that. Or think of any other situation where you want to do something over and over. In programming, this happens all the time, that you want to run something in a loop. Say, for example, an easy example is a mathematical table. So what we did was we wrote 10 lines, one for variable times 1, another for variable times 2, another for variable times 3. What if I put a loop and say run the loop for 10 times, and every time when I am in the loop I say add 1 to A. It adds 1 to A. So 0 becomes 1. And then you multiply it by 1. Multiply by A, the variable. Then the next time loop happens and you add 1, it becomes 2. And using the loop, instead of writing 10 lines, you have 1 loop. What is the benefit of loop? Because if you can write 10 lines, what if somebody wants you for a table of 100? Then the same loop would work. You just tell it, instead of 10, make it 100 times. And things like that. So you will see, loops are like very, very basic, used everywhere all the time. And a lot of things are done using the loops. Now, from a conceptual point of view, there are 2 types of loops. One loop that has a definite start or end, or for a number of times, it will work for a number of times. So what happens is you say this loop will just run 10 times. Somehow you'll tell the loop that you will run 10 times, or 100 times, or 1,000 times, whatever the number. That is a definite value that you want. Or you can run it for indefinite period of time. For example, you guys might have seen some applications where you have to give some value. But once you give it and it does its stuff, it comes back to it again. So it is in a loop which always does things and come back to it, and there is no end to it. It's indefinite loop. We'll see how it works and what are the benefits and stuff, but there are 2 main loop types. There are different, Java provides different syntaxes or different constructs that help us write loops. There are different types of loops other than definite and indefinite loops. And we will go a little bit about it. But we will start with a loop which is called while. Why? So it's very simple, very easy. We have an example of it too. So let's copy the example and run it. So I cannot, to copy the example, I have to, so I will run it anyways, like this. So who wants to run it? Who wants to type it while I am typing it? Musa, I'm looking at you. I don't know why. I don't know why. Maybe I'm thinking that you are a young man and
Smart.
Smart.
I've heard that a lot. I've heard move too.
I'm done already. Sorry, Musa. That's why I was saying who is young here.
You sure you didn't just copy and paste it?
Oh, I did, but nobody was looking.
I was looking.
Oh.
That makes a lot of sense.
Alright. So let's first run it. If it runs, then we will go about it. We'll do a little bit more. Line 8. What is this? Was it something? Alright. Interesting. So, start. Keep writing. I'll tell you. So what we define is, so say this is all part of loop. All those 1, 2, 3, 4, 5. They are not fully part of loop, but will, for conceptual purposes, we will understand it. So what happens is, and let me also while you guys are writing it, I will send, I'll send it to this one also. So you have it. Alright. So what happens here actually is, this is a finite loop, and you can see with the numbers and stuff. Before we do that, right, but this is good. Otherwise, it will be a little bit confusing. We can have a loop without a block statement, but maybe when we'll come to some other type of loop, then I'll show you without a block statement. So what, yeah, it will be good if you run it and then you will, and we can discuss it a little bit more in 5-6 minutes. Yeah, that will be good enough time.